Okay, we are on our last page, or I'm sorry, last page front and back. Additional angle relationship theorems. So these are additional angle relationship theorems. Alright, this one's actually not an additional one. Vertical angles are congruent. You already knew that, right, from Skaves? But this is just telling you you don't have to have the parallel lines cut by a transversal. No need for parallel lines cut by a transversal. This is always true. So if you see two vertical angles, you do not have to have parallel lines cut by a transversal to know that they are congruent. They will always be congruent. All right, so looking at this, I have these two these two vertical lines, right? This line and this line intersects, and 5x and 3x plus 10 are opposite. So I'm going to set it up as 5x equals 3x plus 10. Subtract 3x from both sides, and you get 2x equals 10. Divide by 2, and you get x equals 5. All right, so go ahead and do this problem. Pause the video and do this problem. All right, our last angle theorem. Points on a perpendicular bisector of a line segment are exactly those equidistant from the segment's endpoints. All right, that's a lot, but it's really pretty self-explanatory once we break down the keywords. So perpendicular bisector. Perpendicular bisector, a perpendicular line forms right angles. And then a bisector splits a line segment into two equal sides, two equal parts. So a perpendicular bisector does both. It's a line that forms right angles, and it splits a line segment in half. So a perpendicular bisector of a line segment has points on this perpendicular line segment are exactly those equidistants, which means equal distance from the segment's endpoints. All right, so I'll show you what that means. So example 1 here. Do I have a perpendicular bisector? Do I have one? Yes, I do. It looks like HJ forms a right angle, and it splits GI in half into two equal parts, right? 28 and 28. So this is a perpendicular bisector. HJ is the perpendicular bisector. HJ. All right, so knowing that, what my theorem says is points on the perpendicular bisector, so points on this line right here, are exactly equidistant from the segment's endpoints. So this point is exactly equal from G and H. This point right here is exactly equal from G and I. These two will be the same, right? So I know if I have this line right here and this line right here, these two will be the same. So if this is 39, this will also be 39. If this line right here was 30, this line right here, if I drew it properly, would also be 30, right? If this line was 10, this line also would be 10. They're equal distance from the segment's endpoints. So my question here is, what is HI? We just figured it out. H to I is 39. 39, using the perpendicular bisector theory. All right, so go ahead and do examples 2, 3, and 4. I want two things from you. I want you to label what the perpendicular bisector is for each problem. Tell me which line is the perpendicular bisector, and then also solve the problem. This is asking what is GI, what is PQ, what is GH. So go ahead and pause the video and work that out. All right, we're on our last main ideas page. So let's go ahead and summarize everything that we've learned. So when parallel lines are cut by a transversal, the following statements are true. So we've got our SCAVAs. I accidentally paused the video with my elbow, my fat elbow, so I'm not sure where I left off. But anyway, this main page. When parallel lines are cut by a transversal, the following statements are true. So I already did S when the video wasn't working. I was just talking to myself. So supplementary angles sum to 180. My C of SCAVAs is corresponding angles are congruent. My A, alternate interior angles are congruent. My V, vertical angles are congruent. My other A, alternate exterior angles are congruent. And my S, same side interior angles sum to 180. Alright, so I know that my CAVA box is congruent, right? All of these are congruent. And my two S's are summing to 180. Now I also want to put asterisks by supplementary and by vertical. So if I have supplementary angles or vertical angles, supplementary always sum to 180 and vertical are always congruent. You do not have to have parallel lines cut by a transversal. Those two relationships are always going to be true. The rest of the relationships, you need to have those parallel lines cut by a transversal for it to be true. Alright, so let's go ahead and I'm going to let you do number 2 on your own. So go ahead and pause the video and work out number 2 on your own, and then we'll check it. All right, number 3, vertical angles are congruent. And remember, we don't need the parallel lines cut by a transversal to do that. And then our last theory, points on a perpendicular bisector of a line segment are exactly those equidistance from the segment's endpoints. So what that means is if I have a line segment and I have a line that cuts through it and forms 2 right angles and it splits it in half equally, then I automatically know, remember these are the congruent symbols, right? This means this side is equal to this side. I automatically know the points are going to be equidistant, so if this were 5, this would also be 5, and so on. If this were 15, this would also be 15, right? So if I know that I have a perpendicular bisector, I can use it to solve problems because I know this relationship. Alright, I apologize that this was 3 videos, but this is nothing you can't handle. I will see you in class next week.